Hi everyone, my name is Victoria Carthew and I've just had my own brain break, so I'm ready to learn. Coming up in English, we'll be looking at writing comparative sentences. In maths, we'll be locating positive and negative numbers on a number line. And in science, we'll be exploring how long it takes for planets to orbit the sun. Are you ready to learn? Then let's get to it. You may have heard people say, it's like comparing apples and oranges. But what does it mean to compare? How can we use sentences to compare two things? Today, we'll be shown what it means to compare two text types, comic strips and news reports, and how we can write complex sentences to share our comparisons.
Hi everyone, I'm Rebecca, and today we are going to explore how we can use complex sentences to compare two text types. To do this, we are going to be comparing comic strips and news reports. Before we begin though, let's take some time to think about what it means to compare, what comic strips and written news reports are, and how we can structure a complex sentence. Let's begin by looking at what it means to compare. If I asked you to compare an apple and an orange, what would you do? You'd probably start to think about all of the things that apples and oranges have in common, and also how they are different. So let's do this. Let's compare apples and oranges. What did you come up with? When I thought about the differences between my apple and orange, there were a few things that I thought of straight away. They are different colours. They taste different. They smell different. They even feel different. The orange is rougher and a bit bumpy, while the apple is smoother. Also, apples grow best in a cool climate, while oranges prefer a warmer climate. But I can also think of some similarities between apples and oranges. I know that they are both fruit. They both have seeds, and they both grow on trees. I also know there are different varieties of apples and different varieties of oranges. Apples and oranges also have the same shape. They are round. When comparing, we are looking for similarities and differences according to categories. When I compared apples and oranges, I used my senses to identify categories that can be used to make a comparison. I thought about the look, the feel, where they grow, and so on. This helped me make a detailed comparison of the two pieces of fruit. So let's look now at the two text types that we are going to compare. You're probably really familiar with both comic strips and news reports, so let's just quickly review them. Let's begin with comic strips. A comic strip is a multimodal text that combines more than one form of communication, writing and images, to communicate a story. They are a sequence of drawings, usually in a horizontal strip, either in colour or in black and white. They can be funny or be about an adventure or a mystery. Comic strips are often in a series and use speech and thought bubbles. There was no sound and the images do not move. Comic strips are written to entertain the reader and follow a narrative structure. A complete narrative may not appear in a single comic strip. What do you remember about news reports? News reports are another example of a multimodal text. They follow an inverted pyramid structure. That is, they start with the headline, which is followed by the summary lead or lead paragraph that contains the most important information, often outlining the who, what, when, where, and why. The body of a news report provides additional details about the key information that was summarised in the summary lead or lead paragraph. A news report ends with a tail. This is not critical to the report and can often be left off. Television news reports include features such as images, captions, graphs, charts, and tables to help the viewer understand what they are seeing and hearing. Now that we've reminded ourselves of what comic strips and news reports are, let's compare them. To do this, we will play a quick game. I'm going to tell you a feature or a characteristic that may be found in a news report, a comic strip, or both. If you think this feature or characteristic is a similarity between the two texts, stand up. If you think it is a difference, stay sitting and place your hands on your head. For example, if I was to say purpose, would you stand up or would you put your hands on your head? To answer, you'd need to think if both of these texts, comic strips and news reports, have the same purpose. That is, why were they written? So what do you think? Would we class the purpose of comic strips and news reports as being the same or different? Comic strips are written to entertain the reader, while news reports are written to provide the reader with information. Therefore, this is a difference, and you would end up sitting with your hands on your head. So let's play. Structure. Is the structure of a news report the same as the structure of a comic strip, or is this a difference? Remember, stand up if it is the same, and hands on head if it's a difference. Are you sitting with your hands on your head? If you are, you're absolutely right. News reports have an inverted triangle structure, whereas comic strips follow a narrative structure. How about this one? Contains images and words words could be captions, they could be speech bubbles. Thumbs up to all of you standing. Images and words are a similarity, so I'm sure you all shot up out of your seats. And one last one. How about audio? Is this a similarity or a difference? 100% if you identified this as a difference between our two multimodal texts. Comic strips do not contain audio, while news reports do. The game we've just played together helps us realise that we can identify similarities and differences between these two multimodal texts. How can we express this in a written format? We can use a complex sentence to compare our two different texts. Remember, a complex sentence is made up of a main clause, which makes sense on its own, and at least one dependent clause. The dependent clause provides additional information to the main clause, but does not make sense on its own. It often begins with a subordinating conjunction like whereas, but, because, or until. So, we could write a complex sentence to compare our two texts. Look at this sentence and think about why it is a complex sentence. I can use the following complex sentence: comic strips are written to entertain, whereas news reports are written to inform, to compare these multimodal texts. I know this is a complex sentence because I can see a main clause, comic strips are written to entertain, and the dependent clause, whereas news reports are written to inform, which begins with a subordinating conjunction, whereas. By writing a complex sentence, I am able to clearly communicate to the reader how these multimodal texts are different. Can you think of another complex sentence that could be used to compare comic strips and news reports? During your day, try to think about how you can compare different objects, people, and places. How are you different to a sibling or parent or another adult? How is your cat different to your dog? How is school different to home? Take some time to write complex sentences comparing these objects, people, and places.
Hi, welcome to Mathematics. I can think of many examples of how we use negative numbers in our lives. For example, while aeroplanes can travel 10,000 metres above sea level, submersible vehicles can explore the ocean floor at 6,000 metres below sea level. Here is Annie to show us how to solve problems involving negative numbers.
-3, add 5. 1, 2, 3. Oh, hi there. I was just practicing using my number line. In the last episode, we looked at negative numbers. We placed them on a number line and used it to solve simple problems. Today, we're going to use these skills to solve more complex problems. Let's recap what we learnt about positive and negative numbers on a number line. This is a number line. 0 has been placed in the middle. We know that numbers to the right of 0 are positive numbers, and those to the left are negative numbers. Notice that the numbers mirror each other on either side of 0. The value of each number increases as we move to the right and decreases as we move to the left. A number line can also be written vertically. The numbers above 0 are the positive numbers, and those below 0 are the negative numbers. The value of each number increases as we move upwards and decreases as we move downwards. We can use a number line to solve problems that add or subtract whole numbers. Sometimes we get questions that have more than one part. For example, Sophie borrowed $6 from her sister. Then she earned $8 by mowing the lawn. She then spent $1 on a cold drink. How much money does Sophie have left? You see that to solve this problem, we need to do multiple parts. So let's give it a go on our number line here. Where do we start? Well, Sophie owes money, so she is starting with less than $0. We need to start at -6. Now let's step out the first part. She made $8. In which direction are we going to move? We will move to the right because the amount of money that Sophie has is increasing. 1, 2, 3, 4, 5. Don't forget to include 0. 6, 7, 8. We have stopped on +2. Now Sophie spent $1 on a cold drink. Which way do we move? She is spending money, so the amount of money that she has is decreasing. We move to the left. 1. We've ended on +1. We have now worked out that Sophie has $1 left. Now we will have a go on a number line drawn on paper. We will step out the question in the same way we did on the number line on the board. Blair had 10 biscuits. He gave 5 biscuits to one friend and then another 5 to a different friend. How many biscuits does Blair have left? Where do we start on our number line? Blair has 10 biscuits, so we start at +10. He then gives away 5 of them, so in which direction do we move? The number of biscuits Blair has is decreasing, so we move to the left. 1, 2, 3, 4, 5. We've stopped on +5. He then gives away another 5 biscuits, so we move another 5 to the left. 1, 2, 3, 4, 5. We've ended on 0. That means that Blair does not have any biscuits left. Let's write a number sentence to show this problem. 10, subtract 5, subtract another 5 equals 0. Let's do another. It was 8 degrees when I went to bed. Then overnight, it dropped by 9 degrees. By 10 a.m., the temperature rose again by 8 degrees. What is the temperature at 10 a.m.? Where do we start on our number line? We start at +8. The temperature then dropped 9 degrees. So in which direction do we move? The temperature decreased. This means that we move 9 to the downwards. 1, 2, 3, 4, 5, 6, 7, 8, don't forget to include 0, 9. We've stopped on -1. When the sun came up, the temperature rose again. In which direction do we move? The temperature increased. This means we move 8 upwards. 1, 2, 3, 4, 5, 6, 7, 8. We've ended on +7. We've calculated that the temperature at 10 a.m. is 7 degrees. Let's write a number sentence to show the problem. 8, subtract 9, add 8 equals 7. There are so many ways that we use negative numbers in real life. Later, you could make up some of your own stories, step it out on a number line and make a number sentence. See you next time.
Thank you, Annie. I'm positive there was nothing negative about that lesson. Now, what's next? Yes, it's time for a health chat with Isaac.
Hi guys, and welcome to Health Chat with Isaac. I'm Isaac, and today I'm going to be giving you guys a quick tutorial on how to properly wash your hands and prevent the spread of COVID-19. Now, to protect your health and the health of others, it is really important that we are washing our hands and washing them often. So here are 6 simple steps to follow if you have drinking water available. Step 1, wet your hands and apply soap. Step 2, rub your hands together. Step 3, clean the back of your hands. Step 4, clean in between your fingers and around your thumbs. Step 5, clean underneath your fingernails and rinse with water. And finally, step 6, dry with a clean towel, a paper towel, or shake till they air dry. Now, the experts say we should be washing our hands for up to 20 seconds before they're ready to dry. But counting to 20 to yourself can be so boring. So my tip is you sing happy birthday to yourself twice through, and then those hands should be ready to dry. Happy birthday to me, happy birthday to me, happy birthday dear Isaac, happy birthday to me. And don't forget guys to avoid touching your face. The more we touch our face, the more chances we have of exposing ourselves to germs. Thanks guys for watching, and see you next time on Health Chat with Isaac.
Today in Science, we're continuing our discussions about astronomy, and we're going to explore the time it takes for planets to orbit the Sun. So, it's over to you, Brett.
Our solar system contains 8 planets that all orbit the Sun. An orbit is the path taken by one object as it moves around another object. For example, the Moon orbits the Earth and the Earth orbits the Sun. The shape of a planet's orbit around the Sun is not a perfect circle, it's more like an oval. This means that the distance between the planet and the Sun changes as the planet moves around in its orbit. Today, we're going to explore how long it takes the planets to orbit the Sun. Let's start by using this model to make some predictions about the time it will take the planet to orbit the Sun. Scientists make predictions based on observations and then carry out investigations to confirm if their predictions are correct. Remember, the Sun is located in the centre of the solar system, and the planets in order from the Sun are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. Looking at this model, let's predict which planet will orbit the Sun in the shortest amount of time and which planet will take the longest time to orbit the Sun. Well, I predict that the further away from the Sun a planet is, the longer its orbit will take. So Mercury should orbit the Sun in the shortest amount of time, and Neptune should take the longest time to orbit the Sun. So why would it take more time for Neptune to orbit the Sun than it does for Mercury? I think this is because when we look closely at this model, we can see that Mercury is the closest planet to the Sun. It has the shortest distance to travel through its orbit. In contrast, Neptune is much further from the Sun. It has the longest distance to travel through its orbit. That should mean that it should take the greatest amount of time to orbit the Sun. Based on these observations, we can predict that the larger the distance between the Sun and the planet, the longer it will take for the planet to orbit the Sun. But let's find out if our predictions are correct by examining some data that scientists have collected. Looking at the headings on this table, we can see that this data shows the time it takes for a planet to orbit the Sun. The first column lists the 8 planets of our solar system in order of distance away from the Sun, from Mercury all the way through to Neptune. The second column shows the orbit time measured in Earth days, and the third column shows the orbit time measured in Earth years. Notice that Earth takes 365 days or 1 year to orbit the Sun. We can also see that Mars takes almost twice as long as Earth to orbit the Sun. Wow! Neptune must be far away, because it takes more than 164 years for it to travel just once around the Sun. Now at the other extreme, Mercury takes only a quarter of an Earth year to orbit the Sun. Well, that's only 3 months. This data helps us to draw conclusions about where the planets are located in space relative to Earth. Now, let's use the data on the table to check our prediction. Remember, we predicted that the larger the distance between the Sun and the planet, the longer the orbit will be. Based on this prediction, we thought that Mercury, being the closest planet to the Sun, would do a full orbit of the Sun in the shortest amount of time. The data in the table confirms this. It takes only 88 Earth days for Mercury to orbit the Sun. We also thought that Neptune would take the longest time to orbit the Sun because it's the furthest away. This is also confirmed by our data because it shows that Neptune takes the longest time, about 164 years, to do one full orbit of our Sun. This means our prediction was correct, and we can conclude that the further away planets are from the Sun, the longer it will take to complete their orbit. Now, scientists have also used this data to discover an interesting fact. If Mercury were travelling at the same speed as the Earth, it should go around the Sun once every 139 days, but we can see it actually only takes 88. On the other hand, if Jupiter was travelling as fast as the Earth through space, it would go around the Sun about once every 5 years. Instead, Jupiter goes around the Sun once every 12 years. By studying this data, scientists work out that all the planets are actually travelling at different speeds. Closer planets move faster through space if they're closer to the Sun, and planets further away from the Sun move more slowly. Now we know that an orbit is the path taken by an object as it moves around another object. So the Earth orbits the Sun. The closer the planet is to the Sun, the less time it will take to complete one orbit, and it takes 365 days or 1 year for us to make one orbit of the Sun. And we can use data collected by scientists in their investigations to confirm if our predictions are correct. Now it's your turn. This afternoon, you could calculate how many times each person in your household has gone once around the Sun. What about, though, if they were on Mercury or Neptune? How many times then? See you next time.
Thank you, Brett, but I'm not sure that I want to think too closely about how many times I've gone round the Sun. Let's just say that it's more than 30. Well, we have officially finished our Learning at Home TV lessons for this morning. I hope that you've enjoyed them. Remember that we're back here every Monday, Wednesday and Friday with plenty more learning to share. So until next time, stay safe and positive. Be sure to look after each other and remember the health messages that you've heard today. Bye for now.
Authorised by the Queensland Government, Brisbane.